So we have 6 axes over here. Statistical distribution. GenAI exploded out. Smoother. Yeah, I'm going to get a different plot, but also do Inferno. There are 3 axes. AI/ML is all about data, and often the data that we have is very complex and hard to understand. Being able to visualize the data becomes very helpful in such cases, because when we visualize the data in different forms, plots, graphs, we are able to understand it better. We are able to spot any patterns, trends, outliers. One of the most common Python libraries that is used for data visualization is Matplotlib. It is highly customizable and it integrates very well with other Python libraries like NumPy and Pandas. So this is the crash course on Matplotlib, and by the end of this video, you should feel very confident about being able to visualize the data in any form you like in so many different plots. So without wasting any time, let's get started. But a quick reminder to just subscribe. So many of you have still not subscribed. If you could please do that, it would mean just so much to me. It will really motivate me a lot. And let's get started. Let's get started with looking at the Matplotlib documentation to understand that what are the different plot types that are supported. So we'll have an idea that okay, these are the visualizations that are possible and this is the goal of the video. So let's start looking at the different types of data and how to visualize them. So if we have pairwise data, what do I mean by pairwise data? Meaning that suppose we just have these points corresponding to XY, or tabular data or functional data. What do I mean by functional data? Y equal to 2x, y equal to sin x, y equal to log x. All of these are different functions, right? So you can either just connect these points and like draw a line corresponding to that. It can be a curved line also, straight line corresponding to y equal to 2x, 3x, 4x and so on. Basically mx plus c, or a curved line like sin x or log x and so on. So you can just plot, simple plot meaning you're just going to connect those points. Scatter meaning you're not going to connect those points, you're just going to mark that these are the different points that are there, okay? Now there are a lot of customizations possible in all of these visualizations and we are going to be discussing them and looking at them, so don't worry about that. Then you can also draw bars and stems. These are the usual common ones, but these are also possible. Coming to statistical distributions, you must have heard histograms are very common, pie charts are very common, box plots are very common. So we'll look at these. Gridded data, I think we can skip it for today's video because it's used comparatively less. But yeah, we can visualize the data in coordinate grids also. Plus, if we do so much, I think this should be fairly easy for you to be followed. And then coming to 3D, we will do this. We will look at how to visualize bar 3D, how to draw this, how to plot these kind of graphs or these kind of graphs, plot surfaces, stems, scatters, and so on. The documentation is really good. So let's get started with the tutorials page and let's go to this PyPlot tutorial. And here we can see and get started with a basic graph. Okay, so how can we draw like this line and how can we put all of these numbers? Maybe how can we, label these axes and all of this. So let's get started with writing our code. Before we move it, I would just like to take a moment over here to share something with you. Over the last few months, I think all of us have realized that ML/AI is the future. And that is why you're watching the video. It makes sense to read about it, to study it and be future ready. And I've been doing the same. Over the last few months, I've spent so much time on ML/AI. In fact, we have a product called TaxStop, which is currently live only for the Educosys students. But we are integrating a lot of AI stuff into it and I'm learning so much over there. Also, we have been designing a live hands-on generative AI course. We have finally launched it. It's a 7 weeks course. You can check out the curriculum over here. It has 10 projects, some small, some quite big projects, but it is going to be completely live and I'm just so much excited for it because here you will not only be learning about generative AI, you'll be building, deploying and applying generative AI. The last hands-on course that we did was hands-on high-level system design course, which we call HHLD. That was MERN plus DevOps plus HLD. That is still one of the most enrolled courses on Educosys. I have seen so many students not only develop end-to-end projects, scalable projects, but deploy them and add them to their resume. It was one of the most satisfying things that I have done as part of Educosys, as a software engineer, as a teacher. That's when I decided that I want to do more hands-on courses and I'm really excited for this and it's going to be live. So I hope to see you there. Like all the other courses, you will get access to the recordings, to all the future live batches, and you will get the access to code, notes, everything. You can check out the details, you can check out the testimonials of all the other courses and I'm really excited for this. But for now, let's continue. I hope to see you there. For now, let's continue. Let's get started with writing our code. As you can see, I'm using Jupyter Notebook. I also use this in the Pandas tutorial. Obviously, that is not the prerequisite. This is separate. But this is very easy to set up. If you are just getting started, you can just do pip install Notebook and get started with Jupyter Notebook. You can also set it up on Google Colab or set it up on VS Code. Anything works. Just get started and don't spend so much time thinking about what is the correct way of the installation. Just get started with writing the code. And we are going to get started with first installing Matplotlib. So let's do that. And I'm just going to run this. And what we are going to do now is import. So import matplotlib.pyplot, and we are going to use it as PLT. So this is the usual alias that is used everywhere. So we are going to use the same. And let's plot our first plot. And I'm just going to plot 1, 2, 3, 4. And let me come over here and let me run this. So here, yes, congratulations, we can see our first plot. Now you must be thinking that Keerti, you actually gave only like few values, like where are the corresponding like XY values? So there should be like a pair of values, right? So what happens over here is that by default, it takes the X values to be 0, 1, 2, 3. So you can see that for X equal to 0, Y value is 1. For X equal to 1, Y value is equal to 2. X equal to 2, Y value is equal to 3. And X equal to 3, Y value is equal to 4. It is not like I remember all of this. Just go to the documentation over here. So we started with this, right? Just go down and you will be able to see. I actually just did this, right? Plot 1, 2, 3, 4. You can do anything and you'll be able to see that the X value by default that it is. So actually let me show it to you. The X vector has the same length as Y but starts with 0. Therefore the X data is 0, 1, 2, 3. So it takes it by default, but like this you can give X, Y separately also. So also one more thing. So over here you will see there is that extra line that comes, right? In VS Code, if you're running, dot plot is not actually going to show you the graph. And if you're doing in Jupyter Notebook, you're going to see this extra line. So just do plot.show, plt.show, and you will not see this extra line. And in VS Code, you will be able to see the graph. Okay, and let's try for X and Y separately as well. So suppose I want to see something, right? Like for example, 4, 5, 6, 7, any random values, okay? And let's just draw this and we can see. And you can see over here, it actually nicely puts these values also, right? So it has taken the values from 4 to 7. We can obviously customize all of this. Right now, this does not make any sense because we do not know what these X values are, what this Y values are, what is this graph representing. It is not showing anything, right? So we'll try to make this more sensible and let's do that. But before that, let me show you one more thing. So instead of passing the arrays like this, what you could also do is you could do X equal to 1, 2, 3, 4. And let me actually save it over here. And you could also do Y equal to suppose 4, 5, 6, 7. And let me just paste it over here. And now what you could do is just plot X comma Y. And this is also going to work, right? So if you want like separate arrays, later in the video we'll also see that how we can import the data sets and we can try to visualize that as well. So usually the data is going to be in variables, right? So this is how you can plot. Now let's try to make this more sensible. Firstly, let's give a title, okay? So title of the graph, right? So if you just do plt dot, you will be able to see there are so many things that you can actually set up. Let's just try seeing title. So here we can set that this is the title. So we are just setting the title for the axis and okay. And let's put something. For example, we are trying to visualize marks corresponding to number of hours, okay? Corresponding to number of hours studied, something like this, okay? Random graph. And let's try to see this. And here you can see marks corresponding to number of hours studied. So this is the title. Now suppose I want to see that what is X and what is the Y. So I want to put a label to the X axis and to the Y axis. How I can do that? So just go to plt.x label and here you will be able to pass a string, right? So we can pass a string over here. For example, so here it is going to be number of hours studied. And let me actually do that. I'm just going to capitalize this N. And we can see that X label is there. Now, by the way, I'm running using Shift Enter. You can also run using the play button. Okay, Shift Enter is what I'm trying to run from. Just telling for the beginners. Okay. Now, if you want to put Y label as well, you can do Y label. And here I'm going to put marks, right? Although the marks 4, 5, 6, 7 doesn't make a lot of sense. So let's change the marks to, for example, 90, and our marks are going to increase corresponding to number of the hours studied. So we are just going to put some random numbers, 96, 98, right? So you can see that this is how graph looks like. So this is beautiful. This is a good enough place to get started, right? What else can I customize over here? So if we look at the number of hours studied, the mentioned numbers are 1, 1.5, 2, 2.5, 3, 3.5. So it did it by itself. Okay, maybe I don't want it to be like that. Maybe I want it to be explicitly mentioned, that I want to tell key mention only these numbers 1, 2, 3, 4, or maybe only just 2 and 4, anything, right? So that can also be customized. Suppose we can do something like this. So plot dot x ticks. Okay, so these are the ticks that I want to be mentioned. Now over here I can again give 1, 2, 3, 4. And if I run this again, you will be able to see that, okay, 1, 2, 3, 4. Now in this, suppose I did not want it 3, I wanted only 1, 2, 4. So you can see 1, 2, 4. So it will adjust accordingly. It will show only the numbers that I want. Similarly for y also we can obviously do the same. So that will be called y ticks. And suppose I want only for 90, 95 and 100. Okay. And I can do that as well. So, and it is going to adjust accordingly. Now, suppose I mention 1000 over here. So that is not going to make sense, right? Because 1000 is over here and these numbers are over here. So it doesn't make sense over here. It will adjust accordingly, but obviously give the text that makes sense, right? So you can mention that which text you want to see, which all you don't want to see. Suppose instead of like this, I want to see 90, 92, 94, 96, 98 and 100. Okay. So this looks clean and nice, I think, for now. Now suppose in this only, instead of one graph only, maybe I want to see another graph. So right now maybe we have marks only of DSA. So suppose, you know, students are in college and we are seeing DSA marks and we are plotting DSA marks right now. Maybe there is another subject called, say for example, ML, okay, and let's say ML marks. And let's say the marks over here are suppose 93, 95, 98 and 100. And let's plot these as well. So we can plot in the same graph only. So suppose we want to mention, we want to suppose see the two marks correspondingly together in the same plot, right? So we are going to plot the same together. So x comma ML marks, right? So let me just make this a bit spaced out. Okay, and let's run this. And here we can see two graphs over here, right? Now there are two plots, but we do not know that which plot indicates what. Okay, so we do not know this means what and this means what. So it makes sense to put a label corresponding to it. Like we put labels corresponding to the axis, right? So this axis label was number of hours study. This axis ka label was marks. Similarly, I want to put label to the plots themselves. So what am I going to do? I am going to put label equal to, now suppose this is DSA marks and this is going to be ML marks. Okay, and let's run this. But now you will see ki, okay, we put the labels but we do not see it anywhere, right? So you should be able to see that, okay, this plot means this and this plot means this. For that you can have something called plot.legend. Okay, so this is going to actually show that what all things, what all plots you have plotted. So here you can see DSA marks and ML marks. And you can also mention the location of this thing. So I think we can give like this, location equal to, we can give anything, suppose lower right, and you will see that, okay, so this is not coming, I think it is log and not location. Yeah, so you can see it is on lower right, right? Similarly, we can also give upper right, and yeah, we can see upper right like this. We can also tell ki where we want the legend to be. You can obviously also put it outside, like such things are also possible. So we have seen two plots in the same graph right now. Let's see what other customizations are possible. So if we go and plot and I just type C, okay, and if I just go down and look at the documentation itself, I should be able to understand that what all things can be done. For example, if I go over here and I check out, I can actually put marker size, line width, color, marker, line style, right? So let's try all of this. What is line width and what is this GO dash dash? So let's try all of these things. Suppose we start with color. Now color, I can just mention R, and if I just run this, you will be able to see that for DSA marks, now the color is red, right? I can also give it as just B, it will take by default blue. So these are like the unique colors. Otherwise, I could also mention something like entire red. So you can see it is red. I can give black, right? So it will become black. I can also give hex values. So I could give 1, 2, 3, 4, 5, 6. So if I give 6 zeros, it will again be black. I can also give like something like 00F. So it will become blue, or 0F0, it will become green. So like this, you can play around with this. Like for example, I want to write just green specifically. So okay, green, okay, this is like hash was there. So green it took, right? Like this, I can mention more things like, so if I go down in the documentation itself, I can see line width, right? So if I go to line width equal to, for example, 10, and let's run this now. See, this is too much. So let's maybe change this to 5. So 5, okay, so we have a bold line now, right? Other than that, I can also mention marker. What is marker? I can give, suppose, asterisk, and if I run, so the marker is very small and the line width is a lot. So maybe let's make the line width smaller. Now you can see this markers, right? Now marker, I can also make it of different color, and I can also put different markers. Now you must be thinking that, Keerti, how will we remember that, what all markers are possible, what all things are possible? So again, just refer to the documentation. If I again go down, so let's go down a lot. Here you can see these are the different markers that are possible, right? So these are the characters that are possible. So we can give dot, comma, we can give less than, greater than, 1, 2, 3, 4, we can give asterisk, we can give plus sign, this sign, right? So all of these are possible. Then line styles. What are line styles? So suppose let's give line style equal to dash dash. And if I do this, you will see that the line style is now dash dash, right? Marker, let's maybe put it like a pipe operator. And if I do this, you can see a small marker, right? Maybe let's change this to asterisk only. And line styles, again, there are so many possible. So let's again check in the documentation which are the line styles that are possible. So we gave dash dash, they can be dash, they can be dotted line style. So you can give like colon kind of thing. So solid line is simple. Right now there are different format strings also. Again, blue markers. So these are red circles. So OR, dash G, so green solid line, dash dash, dashed line with default color, right? Black triangle of markers connected by a dotted line. So you can give like this. So these are different formattings that are possible. You saw that we saw red, right? So R means red, M means magenta. So if you want to try M over here, it will become magenta. Okay, this, let me just remove this, sorry. And now this is magenta, right? And there is also something called shorthand notation, but that is positional, okay? So it is not going to work everywhere. Actually, let me just copy paste so that, because the code is available in the description. So in case you want to refer to all the styles of the code, so just copy pasting. Here what you can do is you can mention shorthand notation and you can give something like this. So red color, marker in asterisk and dash dash, right? So it takes color, marker and then the line style. So this is the shorthand notation. So you can see that it became red, asterisk and line style, right? Now if I actually, this is positional and let me show it to you. So if I put it over here, it is not going to take it by default. So make sure that you put it in the right location. And let's check out more things that are there. Okay, we have seen line width, we have seen style, color. I think this is good enough. Marker size also we can check out maybe. Okay, so suppose, okay, sorry about that. Suppose we have to give marker size to 10 and let's run this. Now you can see that the marker size is much bigger, right? And you will actually be able to see in the legend as well. Suppose we want to make it very, very big just to see. Here you can see it is so big, right? So you can also make it small. You can also make them transparent. There are a lot of things to play around with. When we explore different kinds of graphs, we'll play more with this. So I think you get the point, right? Now, other than playing around with this particular plot, we can also customize these things more. Like for example, the title, okay? Now in the title, I can give something called font dictionary. So you can see font dictionary, and what it expects is obviously a dictionary. From the name itself you can understand. Now in dictionary you can mention a lot of things like font size, font weight, color, vertical alignment, horizontal alignment and all of this, right? Sorry about that. And let me actually write the dictionary. So for example, font name. So I can give something like Arial. I think Arial, it is already there, so I will not be able to see the difference. Times New Roman. So look at the font now, and if I change it, can you see the change? If you cannot see the change, let me actually change it further. Comic Sans MS, and if I run this, now you can see, right? Now suppose, for example, font weight, right? Okay, we have to give in dictionary, and let me actually put it in separate lines so that you can see all of this. Now suppose font, okay, sorry about that, font weight, and suppose we make it 10, and we can also play, for example, color of this, right? So we can suppose give it blue, and let's run this, and color it is not taking because we have not put it in the as a string. And let's check this. Okay, I'm sorry about this. Let me run it again, and now you can see it is in blue color. The font name is Comic Sans. The font weight is 10. You can again play around with it more. If I make it 20, it will become 20. And also you can do this not just to the title but also to the labels. So if I just copy paste it over here, and suppose over here I want Times New Roman, and suppose here the font weight that I want is 5, the color that I want is suppose red, okay, and the same thing I want in the Y label also. So let's try that out. So you can basically make it look however you want. You can make your plots according to you. So marks, number of hours studied, you can see are in red like this, right? So we can play around with this as much as we like. Whatever plots we are making, we can also save them in any format we like for example, PNG, SVG, PDF, JPEG, anything, right? So let me actually show you how you can do that. So you can do something called plot.savefig, and you can see over here, save the current figure as an image or vector graphic to a file. So let's try it out. So I can save it with the name suppose marks.png, and I am mentioning the format over here itself, right? Also, it is going to save in the same folder where your notebook file is present. So let me run this and go to the file. So here you can see here there is marks.png present, and if I open it, you can see it looks like this, right? You can play around with it more. In fact, suppose for example, you can mention the DPI, okay, and you can see in the documentation itself they have given everything, the DPI, the format, the transparency. So you can mention, so currently you saw that it was white background, right? So if you want it to be transparent, we can give that as well. So let's try DPI. Suppose we want it to be of very low DPI, okay? Obviously 10 is going to be very less, but I'm just showing you to show that, okay, the resolution can be very less. Like for example, DPI is basically dots per inches, which obviously means resolution. So low DPI will mean lower resolution. If you want your images to be very lightweight and you just want to see how it is, if you want to save on memory, you can have low resolution images. Not so low, but yeah, let me actually show it to you. So here if you go, you will be able to see that this is very, very low resolution, right? So let me go back and let me actually increase the resolution to say 100. Let me save it again and go back over here. You can see it became better, right? But now also when I zoom in a lot, you can see that it is still becoming blurred, correct? So let me go back and make the DPI as say 1000, and if I go back over here, you can see the resolution is actually much better now, right? So this is how you can mention the resolution. You can also give transparency. So suppose transparent equal to 1, and let me just run this, and if I go back, I think it is loading. Let me just run it again, and you can see it is transparent. One small thing to note over here is that save your figure before you do show. Let me actually show something to you. So we have the figure that is there, right? So it is there in marks, and if I open it, it is there, correct? Now if I actually delete the marks figure, so let me actually move it to bin, and if I put it later, okay, so if I do it after the show, and let me run this again now, and if I see this marks, it is essentially empty now. There is nothing inside this. Why this happens is, see, the details are out of the scope of the video, but just wanted to tell you this, that what happens is that once show renders something on the screen, it clears the current figure that you're working with, and unless the mode is interactive. So that interactive mode part is out of the scope of the video, but just remember this, that you should be saving the figure before show, and you are going to run into some problems, right? Which is fine, like just check on Stack Overflow, all of these problems people do have. Also, one more thing I just noticed that we have assigned font weight and not font size. For those of you who do not know the difference, see, font weight is basically bold and like thin kind of thing, and font size is the size of the font. Okay, so let me actually show that also. So if I have to give font size, so let me actually give that. So suppose font size of the title, we keep it say as 20, and font size of the label suppose as 5. So just to show that those are two different things, I hope nobody gets confused by these little things. So you can see that this is pretty big, right? So this is 20 and this is very small because this is 5, right? So if I make it 10 and in both the labels, so if I run this again, you can see that this is 10 and this is 20, right? So yep, just play around with it. You are going to run into problems, you will learn. It's fine. The documentation is very good. Stack Overflow, I'm sure people would have run into a lot of problems, which is fine. You will figure it out. Don't worry about it. Let's go back to the documentation and check it out. So this is fairly simple to understand. We have already done plot, y label, show. This is fine. This is also fairly simple. RO stands for what? R is red, O means circles. So the markers are in circles. So this is simple. This example seems very interesting and let's actually check it out, this one. Okay, and let me copy paste it and let's try to understand it. Okay, so here firstly, why have they imported NumPy? See, NumPy is just to generate some arrays. So here np.arrange, what are we doing is generating one array. Let me actually print t and show it to you. Okay, and I'm just going to comment this out for now and let me run this. And here you can see there's an array starting from 0 ending till 5. Okay, so this is the start value. This is the end value, which is not inclusive, so it is ending before 5, and this is the increment value. So start from 0, increment with 0.2, so 0.2, 0.4, 0.6, 0.8 and so on till less than 5. So suppose we had given 5.2, so then 5 would also be included, right? So this is how we are generating the array, and after we have generated the array, we are plotting it. Now this plotting also seems very interesting here, okay? So what is happening over here is essentially, let me actually show it to you. Here there are 3 plots that we are doing, okay. So this is the first plot, this is the second plot and this is the third plot. So this is first plot ka x, y and this is the shorthand notation. Shorthand notation means R color and then dash dash, right. So red color and then dash dash. So x, so y is equal to x, so t comma t and red and then dash dash. Over here this is x. What is y? This is x square, right? So this is x square. Show it in blue and make the marker as square. So it is in blue color with square. The third one, this is again x. This is x cube. So this is x cube. If you do not believe me, just see. So 5 cube is what? 125. That is the value is greater than 100, right? 4 cube is what? So you can actually check out the values. This is x square, this is x cube and this is x graph, okay? And this is in green color and the marker is this triangular thing, right? Similarly, the graph that we had made, right? So I had written 2 separate plots. Here instead of that, we could actually combine the plots and given shorthand notation. So let me actually do it and show it to you. So if I just, okay, instead of, let me just comment it out so that it is still there for the reference. And I'm commenting out legend as well because I'm not giving labels now, right? So legend is going to expect labels. If I don't give labels and I don't comment it, actually let me show it to you. If I do this, it is going to, okay, this is indentation. If I run it, you can see the legend is going to give a problem because there is no argument. We haven't mentioned any labels. Let me comment this out and let me run it again. Now you can see here again there are 2, right? So the DSA marks was 1. So here it is red and like this. So here I can give something like this. Suppose green color and suppose again make it a plus sign and suppose dash dash only. Okay, and if I do this, if I run it, you can see it is like this, right? So this is how you can give multiple plots in the same function itself. So in one plot call, you are actually making 3 plots, right? So this is another interesting thing that you can try it out. In this example that we had taken, what we did was there is one plot and we plotted basically 3 different data points or plot points, right? Now what if your scenario is that I don't want them to be plotted together, maybe I want them to be plotted separately. Now listen to me very carefully. This is slightly tricky but very interesting. Let's try to do something very interesting. And once you understand it, it is going to be very clear, and we are going to look at the code also. So it will be clear. Just listen to me very carefully. So here now in Matplotlib, there is a concept of figure. We always have a current figure that we are working with. So when we did save fig also and we saved in PNG, what we did was we saved the entire figure in this PNG file, right? Now there are two things that I can want when I want them to be plotted separately. One thing that I can want is plot in separate figures only, which means that when I do save figure, they are going to be saved in completely different figures, okay? They are going to be exported as different PNGs, PDFs and all of that. So they will be different figures altogether. Now another thing that I can want is in same figure, I want 3 different plots. In that case, the term that we use is subplots. So I want in one figure, I want 3 subplots. Let me show you the code. Let's use the same example from the documentation and let's try to make it more interesting. Okay. So now what I'm going to do is, okay, let's use this T only. Okay, and what we are going to do is create one figure right now. So when I do plot.figure, let's see what the documentation says. It says that this is going to create a new figure or activate an existing figure. So I am going to create a new figure right now, and then I am going to just plot this first. So this is the first graph that we had made, right? So this is like a plot point that I am taking, or this data point that I am taking, okay? And what I am going to do is I am going to do plot.show. Now for the other two, I am going to create new figure. So for those on also there will be separate dot figure and there will be separate dot show. So now these I am going to copy paste. This is going to go to my second figure, and this is going to go in my third figure. So you get the point that I have created 3 separate figures now. So when I do save fig also, I will do separately for these figures. And now when I run this, you can see this is one figure, this is another figure, this is another figure, and I can do obviously all the styling that we just went through. Obviously I can do for all of them. I'm just focusing on the plot right now. Okay. Now another thing that I could do is I could create only one figure and have these 3 as subplots, so that when I am exporting, when I am working with the figure is same, but these are subplots. Okay. So for that, what I am going to do is I am first going to copy this. Now because it is one figure, I am not going to do dot figure and dot show again and again. So I am going to remove this dot show dot figure, dot show dot figure. So now what is happening is there is only one figure that I am working with, but these 3 are supposed to be subplots. So I am going to mention that subplots. Okay. Now how should these 3 subplots be plotted actually? How should they be plotted next to each other? So my figure, what I am going to do is I am going to divide it into say 3 columns so that I can put my 3 subplots over there. So I am saying have one row, have 3 columns. So if you actually go through the documentation over here, it says mention the number of rows, the number of columns and the index where you want to plot right now. So I am going to say the number of rows is 1, the number of columns is 3. Okay, so I want 3 subplots and put it at first index. Now similarly for the second one, what I am going to say is again 1 row 3 columns, but put this one at the second index. Similarly for the third one, what I am going to say is 1 row 3 columns, but put at the third index. Now if I run this, see, so there is 1 row 3 columns and the 3 subplots are at the 3 indexes. So 1, 2 and 3. Similarly, now what I could also do is, suppose I didn't want the subplots to be horizontally next to each other. Maybe I want them to be vertically next to each other. So how many rows do I want? 3 rows. And how many columns do I want? 1 column. Now again I want 3 rows, 1 column, but now second index. Again 3 rows, 1 column, but now third index. Now if I run it, see 3 rows, this is 1 column and first index, second index and third index. See, again repeating, what happened over here was that in this example that we had one plot, one figure. Okay, these were just different plot points or different data points that we are plotting in the same plot. Now here what happened was that these 3 are different figures altogether. So saving will be different, everything is different. So different figure. Okay, so when I do dot show, that figure is cleared out. Okay. Now over here what I am doing is, this is one figure but these are different subplots. So here the subplots I am just putting them horizontally next to each other. So there is 1 row and 3 columns. Here I am putting these subplots vertically next to each other. So there are 3 rows and 1 column. We will take more examples. Don't worry, it will be clearer. If you have any doubts, just watch it again. The timestamps are present. And if still you have any questions, let me know in the comments. I will help you out. Don't worry about it. Now suppose in the figure with subplots, what if we want to add, say, titles for the subplots as well as for the overall figure? So let's actually try it out. I'm just going to take the horizontal one as the example. Now what we can do is actually add the individual titles. It's very simple, nothing much, right? So I can add the individual title like this. Let me call this linear subplot, and like this let me add for all the 3 subplots quickly. And if I run this, I can see that individual titles are there. Now, what if I want the overall title for the entire figure, right? So for that, we can do something called subplot. So if you subtitle here, you can see add a centered subtitle to the figure, right? So we just have to give the string, suppose different functions of t. Okay, I can give it like this, and if I run this, you can see different functions of t and like this. Now here you can see there's a bit of overlap, right? So the spacing is an issue. So for that you can do something called tight layout. Here you can see adjust the padding between and around subplots, right? So this helps us with the spacing issue. So now if I run this, you can see there is specific issue, there's spacing between them, right? Similarly over here also you could do the same thing. Let me actually add the titles. So here also you can see that the 3 subtitles are separate and this is separate. Again there is a spacing issue. So again I can do dot tight up layout. And here you can see, so this is also better now, this is also better now. We can similarly add the x and the y labels as well. Suppose we want the x and the y labels to be same for now, okay. Suppose I just want them to be like, for example, t values and output values. Now what if my label values that I want are separate? Right now I have t values and output values as the same label, but what if I want them to be separate? Firstly, this does not look beautiful, so let me actually make it better. So here you can see, I can see only in one graph. Here also I can see only in one subplot. One very simple way of fixing it is that how I am adding x label, y label throughout, like because it is common. Instead of that, just add how we added title, right, for each of them separately, for all the subplots separately. Similarly over here also I will add separately, right. So if I do this and if I run, you can see that the x label, y label is put properly, right. Similarly over here also I can do it. And again all the styling that we saw, the font size, the marker size, all of that can be done over here as well. I am just showing you for the subplots, right. So for both of them we are able to see very nicely output t values. There is one more way of dealing with subplots, and for that I wanted to understand one more term, which is AXES, axis, okay. So every region where we do some data visualization is basically an axis. So every figure has an axis. Now in this figure, when we have divided the figure to 3 subplots, there are 3 axes. If we create 6 subplots, there will be 6 axes, right? So every single axis is going to have its own x-axis, y-axis. So do not get confused with x-y axis, okay? Basically the region is called axis. Now x-axis, y-axis, every axis will have its own labels, the tickers, the grid and all of that, right? So now when we actually create the figure, at that time itself we can use something called subplots, okay. So earlier when we had to create one subplot, what were we using? Subplot, single plot. Now while creating the figure itself, we are going to say subplots. And if you go to the examples and check it out over here, let's go to the documentation. So here you can see that we can do plot.subplots, plt.subplots, and we will get figure and the axis in the return. Okay, and if we go through the documentation, you'll be able to understand more about the axis over here. We will write this down properly and you will get the idea. So here we can mention the number of rows we want, the number of columns we want. So here we are creating a figure and a set of subplots. So here how we had created one figure and then created one subplot. Here what we are going to do is we are going to create something like this. So figure comma axis equal to plt.subplots, and here we are going to tell the number of rows, suppose 2 rows, 3 columns. We can also give other things like fixed size and all of this, the size of the figure. Okay, so we can give all of that as well. But for now that we have created the figure and the axis, what we are going to do is all the 6 axes that we have. So what are the number of axes that we have? 2 rows, 3 columns. So total number of axes is 2 into 3, 6. So for each of the axes, we can have their own title, their own labels and all of that. Let's try it out. Okay. Till now we have been using this arrange function to generate X, right? Now let's use something else. So in fact, in this example itself, if you saw, we use something called linspace. If you went through the documentation where I was showing subplots, there also they have used this only. So in arrange, what happens is this talks about the step, right? And we were doing from 0 to 0 0.2, 0 0.4, 0.6 and so on. So here what happens is 0 to, say for example 10 and 100. So here the 100 is the number of points that we want to be generated. So from between 0 and 10, here 10 is inclusive, generate 100 points. And if you want to actually see that, we can see it like this, right? So right now also you can see there are 6 axes or 6 subplots that are added, simple ones, and we printed X, right? So these are 100 points between 0 and 10. These are evenly distributed, right? So you will see 0 0.1, 0 0.2 and so on. These are evenly distributed, 100 points between 0 and 10. So this is how we have 6 axes now. Now we can fill these up. We'll fill them with our plots and we'll put the labels and everything. So let's do that. So how I can access each axis is something like this. So axis 0, 0 means that I am dealing with this axis, right? So here I can do dot plot, and here what I am going to pass is X, and let's take sign. Okay, let's take something different. So in NP there are all of these, in NumPy basically there are all of these functions. So let's do sin X. Okay, and if I just run it, you will be able to see already sin X is there. Okay, and in this same axis what I can do is I can add more things, like for example I can do set title. So when I do set title, I can suppose write sin function, and similarly I can do suppose set X label, and we can suppose just write X for now. Similarly Y label, and if I run this, you can see here X label is X. Okay, it is overlapping. So what are we going to do? We are going to do plot dot title layout, and let's do this. So here you can see X, here you can see Y, sin function. Okay, so this is the title of this axis. This is the label for the X, and this is the label for the Y. So X label, Y label and all of this. Similarly, we can fill for all the axes. So let's do that. So this one will be which? This is 0th row only, but first column, right? So let me update the column over here. So just how we had sin function, I am going to use cos function now, and let's have cos. So rest is same. Let's run this. So here you can see cos X, Y. Similarly, let's update for rest as well. So sin cos, let's have tan as well. And this is 0th row, second column. So I am going to update the column to 2. So here you can see this is the tan. Suppose let's have exponential, and this is going to be the first row and 0th column. So first row, 0th column. So here we can see there is sin, cos, and we have to update all of this. So when we had tan, so sin, cos, and here we should have tan, and let me add tan over here as well. And here let's use exponential, and let me write exponential function over here. Suppose we want square root function, Suppose we want log x. Let's run all of this. So, okay, log x, because we are starting with 0, so let's start with 1. And here we can have like a simple linear function. So, I am just going to leave x as it is. And let's run this. Beautiful, right? So, sine, tan, exponential, I think I ended up removing cos, exponential, square root, log, linear, right? So, we have all of them. So, 0, 0, 0, 1. So, I actually updated 0, 1 again. So, okay, this was the problem. So, 0, 1, 2. So, 1, 2, 3, 4, 5, 6, 7. So, I have 7. So, this is an extra. So, let's remove this. So, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, right? So, we have 6 axes over here: sine, tan, exponential, square root, log, linear. So, this is how you can play around with it. This is one figure with 6 subplots, 6 axes. I think it's time that we finally get started with looking at different plot types. So, let's get started with scatter. Just like we did plot xy, we can also do scatter xy. Let's check out the code. So, what I'm going to do right now is generate a random array. So, I'm going to use np.random and I'm going to generate 50 numbers. So, let me actually print x and show it to you. So, when I print x, you will be able to see that I have generated 50 numbers, but all of them are between 0 and 1. So, suppose I want the range of the numbers to be between 0 and 10. So, I can just multiply this by 10. So, now all my numbers are between 0 and 10, right? So, you will also find 8 point something, 9 point something. So, all of these are between 0 and 10. Similarly, I am also going to generate my y. So, x and y both are between 0 and 10 now. Now, I can just get started with plotting. So, let's just do our first plot. And here we can see we can mention so many things. We are going to check all of these out. But this is a scatter plot of y versus x with varying marker size and or color, right? So, let's just scatter x comma y and let's run this and we can see a nice graph. So, if we do not want this, we can just do plot.show and let's run it again. Okay, great. Now, let's see what all things we can mention over here. Suppose marker. Okay, so let's get started with marker. Marker again can be asterisk plus anything. It can be P for pentagon. So, you can see pentagon marker over here. It can be H for hexagon. So, you can see hexagon marker. I hope you can see it over here. It can also be, say, D for diamond. So, you can see it looks like diamond, right? So, let it be diamond for now. We can also give edge. So, you can see edge colors. So, suppose I want to give black, I can also give hexadecimal. But so, if you want, I can also mention it like this, FFF. And if I run this, you can see it's blue. Suppose 00F, you can see like this, right? So edge colors we are mentioning. So actually the edge, you are able to see it very less right now. Suppose let's make it all black for now. And what we are going to do is so you can see now, right, that the edge color is black. What we can also do is give line widths. So suppose I want to make the line width of the edge as bigger. So suppose 10, I think that will be too big. As you can see, the line width is so big. So let's suppose give 5 and you can see this is still very big. Let's suppose give 2 and you can see this is also significantly big, but just to show. Okay, so edge colors, line widths, you can give more things and let's actually see what all things we can give. Marker, C map you can give. You can also give alpha. Okay, why would we need alpha? So let me actually show it to you. Suppose we have a lot of numbers. Okay, right now I have 50. Suppose I have 500. And let me actually run this. Now you can see that a lot of points are actually going to overlap with each other, right? So suppose you want to see that where the overlap is maximum. So what you can do is you can make this as transparent. So when I give say alpha equal to 0, if I run this, you can see it's all completely transparent. And when I do alpha equal to 1, it is completely opaque. So you can give somewhere in between. Suppose if I give 0.5, you can see it is slightly transparent, like the middle value, and you can see where all it is overlapping a lot. So if I give say 1000, you will be able to see even more overlapping. So if I do this, you can see a lot of overlapping now, right? So suppose I give 0.7, you can still see where all the overlapping is there. Suppose if I give 0.3, you can see it is more transparent and I can see overlapping better. So like this, you can give more things. For example, line widths we saw, colors we saw, Here you can see S also, right? So let's give S as well. S is nothing but size. So suppose I give 20 and I run it, you can see this is the size. Suppose I give 100, you can see that it is much bigger. So you can also give the size of each point. Suppose I give it 50, you can see the sizes are varying, right? Similarly, I can also give label over here, just like we gave in the plot that we saw earlier. So here, if suppose I give some random label, okay, and I run this, now in order to see the label, what we have to do is, just like the previous one, we are going to do plot.legend and we are going to run this, and it is not running because I guess because we have given after show. So let me actually give the here and run it. So here you can see random. Just like earlier, we can also give the location. So if I give the location to say lower right, we'll be able to change the location of the legend, right? Also, in all the plots for that matter, we can also give something called plot.grid. So if I set this to true, you will be able to see a grid in the background, and this is true for all the plots. So if I change the number of the points, I think you'll be able to see it better. You can see a grid in the background, right? So this is how you can use a scatter plot. Coming to our next plot type, which is bar. So we can just give bar x comma height. Let's check out the code. So when do we use bar graph? First of all, we use bar graph when we have some categorical data. For example, we have some categories and we want to show these are the values corresponding to these categories. So let's take an example. Let's check it out. Let me actually put some headings over here. So here, for example, this was the scatter plot, right? So let me just write this. And now we are going to create bar plot. So okay, and let's get started. So suppose our categories are different courses that we have at Educosys. Okay, so let me call it courses, and what are the different courses that we have? These are going to be our categories, right? Okay, so let me just quickly write them down. GenAI, HLD, we have HHLD, we have LLD, we have TSA, and we have CPP. So these are the different courses. So these are our categories. Now suppose number of students enrolled for each of the courses, right? So these are the corresponding values. So courses is going to be on the x-axis and students is going to be on the y-axis. Suppose number of students enrolled for each of the courses. Okay, so 2500, 3000, 3200, 2800, adding some random values, 2700, 3500. 1000. Let's give a smaller value and let's run this. Okay, so now what we can do is we can just plot our bar. So all I have to give is x comma y. Our x is courses and our y is students. And if we run this, let's also just write plot.show, and if we run this, you can see the nice bar graph, right? We can obviously play around with this. There are so many things that we can mention. Let's go through them. One is that we can mention width. So we can see by default the width mentioned is 0.8. So suppose I give width as 0.5. So here you can see that the width of the bars is becoming smaller. What else can we give? There is something called align. Now what is align? Align by default is given center. It is given that it can also be edge, right? So if I give align as edge, what is going to happen is that you can see this name that was coming of the category. Now it is coming at the edge, right? So if I go back to the default value, which was center, if I go like this, you can see that the name is coming in between the bar. If I give edge, it is going to come at the edge. So this was the default value only. So let it be for now. What else can I give? Suppose for this, okay, for the edge, suppose I want to give another color. Okay, so suppose we give edge color equals, suppose, black itself, and let's run it. So you can see that the edge has black color. Now suppose I want to give line width. So suppose we give it as 5. I think that is going to be very big. Yep. So let's make this to 2. So you can see the line width, right? So suppose we want to make it bigger, 3. Another thing we can give is color of the bar. So right now I think it is like blue by default, right? Now let's put it red. So you can see it is red. Another thing that we can give is something called hatch. So if I give hatch equal to asterisk, you can see that it becomes like this, right? Now another thing that we could do, very interesting. So let me just copy paste this. Let me show it to you. So now what I'm trying to do is that I want different hatches in each of these bars, right? Something interesting. So let's try doing that. What I'm going to do is I'm going to create a different array called hatches, and I'm just going to create an array of different hatches that I want. Like for example, this, just like we added asterisk over there, I'm going to add different hatches that I want. If you're adding this slash, remember to add 2 slashes. And now instead of giving hatch over here, I am going to write a for loop. And in that loop, so I am assigning this entire plot.bar to bars, and I am going to iterate through bar and hatch in. So I need to iterate through multiple iterables over here. So I can use a function called zip. So what it does is basically yield tuples until an input is exhausted. So basically this is just to combine two iterables. So I'm just zipping bars and hatches together. So I'm going to go through each bar and hatch, and for each bar what I'm going to do is I'm going to assign, so I'm going to do set hatch to hatch, and let's try running this. Hopefully it is going to work. So nice, beautiful. Also, I'm not mentioning in all the graphs, but obviously we can put x label, y label, x ticks, y ticks in all of the plots that we are doing. I'm just going to quickly put it just to show it to you. Similarly here also, let me just add it. Again, the fonts can be changed. This can be played around with. All of this can be styled. Ticks can be mentioned. Like for example, over here, I can give x ticks, y ticks. Right, so here I have changed the ticks. Similarly over here also I can change the ticks. I can add grid, right? So all of that can be done. So if I just do grid true, you will be able to see the grid as well. I'm suddenly in the mood of making this even more beautiful. So let's do one more thing. I am going to assign each of these bars different colors also. So what I am going to do is, I guess you guys should feel confident about this, that you can do all of this, right? So magenta, yellow, orange, how many colors is that? 4, 5. Let's have one more, suppose green. And instead of giving color over here, I am going to add color in bar colors, and for each of this bar I am going to set, you can see we can set so many things, right? So we can set the edge color, face color, everything. Let's set color, and okay, and you can see that this is going to set the color for us, and we are going to set it to color, and let's run this. Beautiful. But I think what happened was that the edge color also got overridden, so we can also set edge color, I am guessing, over here. So if I set it to black, I think looks nice, right? Let's get started with our first statistical distribution, which is histogram plot. Let me just quickly put the heading, just give me a sec. And what is the difference between histogram and bar graph? Because they look so similar. So let me know in the comments. I would like to know how many of you understand the difference. I'm obviously going to explain, but they look so similar. So I am very keen to know how many of you understand the difference. See, in histogram, what happens is on the x-axis, we have continuous distribution. For example, exam scores. Okay, now exam scores are from say 0 to 100. Now I want to see how many students are there who got the score between 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So I'm trying to understand the frequency of students in each of the range. Okay, let me take another example. Suppose ages. And it is not like I have the information that there are so many people of this age. There are so many people of this age. So it is not like I already have the frequency. I just have random ages with me, and let me show it to you. So I'm just adding some random data, okay? And just give me 1 minute. So these are the random ages that I have. 45, suppose 21, 98, 54, 76, any random ages. Okay. Now what I'm going to do is age plot dot histogram, and I'm going to just pass ages to it, and that's it. Let's do plot dot show. And when I run this, see, I got a histogram. Now notice another difference between bar graph and histogram is that in bar graph there's always spaces unless you adjust the width like that, but in histogram there are no spaces when the distribution is continuous. Okay, so what happens over here is that, let's see first of all the number of bars that are there. In histogram, each of these bar are called bins. So I can also I can also tell that how many bins I want. Suppose I want the bins equal to 7 or say 5. If I run this, I will be able to see there are 5 bins. 1, 2, 3, 4, 5. Now if you want to understand what are these numbers that are allocated to it, actually let me show you something. Let's sort these ages. Okay, so dot sort, and I'm just going to pass ages to it, and let's print the sorted ages. So once I do this, you can see the sorted ages over here, right? Now what happened is that it calculated the maximum of this ages, which was 98. The minimum I think is 21. So it would have done 98 minus 21 divided by the number of bins I want, which is 5, right? And then it would have allocated accordingly to the range of the bins. So these are the ranges of the 5 bins. Okay. Now if we see over here, in this range, in the first range, it is saying there are 3, the frequency is 3. Okay, so 21, 23 and 34. So till 34 you can see are in this bin. Then you can see that 45 and 54, I think. No, only 45 is in this bin because the value is, the frequency is 1, right? Then again in the next one, the frequency is 3. So it is saying 54, 54, 67 is in this bin. Then in the next bin, the value is 2. So 76, 78 are in this bin and 98 is in this bin. So it is showing us the frequency. So by default, what it shows us is frequency histogram. There are also 2 more types of histogram, density histogram and cumulative histogram. So I can actually put it over here that what is the kind of histogram that I want to see. So if I do cumulative equal to true, so by default it is false. Okay. Similarly, density also by default it is false. So if I do density equal to true, what it is going to do is it is going to normalize the frequency for us. Basically, the total area of the histogram is going to become 1. So it is going to do probability distribution, which is details for like another video, not today. Cumulative is what happens is that it adds up the value from the previous bin, right? So as the name suggests, cumulative. We are not going to be discussing that into a lot of detail, but this is what you can do. Also, all the styling that you were doing in bar graph, you can do over here also. You can put the width, line width, alignment and all of this. One interesting thing that you can do over here is orientation. So if I give orientation equal to horizontal, you will be able to see it. Okay, sorry about that. You will be able to see it like this. So you must have seen voting data, right? Like when voting happens in India, US and all that, you must have seen that this is the graph that you usually see. So because it is very famous, you are able to compare it very nicely. So you can give orientation, you can also give width and all. So if I give say line width equal to 2, sorry, and suppose I want to give edge color, suppose black itself. I'm not covering all the styling again and again, just covering quickly. So let's run this. And what we can also do is add labels. So let me actually just copy from this. And suppose X label is over here frequency, because we have done horizontal. So I'm just going to put frequency or the count and ages, right? And we are going to say ages plot, and let's run this. So here we can say it like this. Let's move on to pie chart. Let me quickly put the heading. And we are going to be using the same data as we used over here. And let me just copy paste that. So we again have courses and students, and what we can do is just to plot.py and pass. So students is our main thing, right? So we want to see how many students took which all courses. So what is our label over here? Our label is going to be the courses, right? So if I run this and show it to you, very simple, right? And let's just write plot.show. And here you can see it like this. Simple, nice, right? We can play around with this, make it look better. So let's do shadow equal to true. It's going to look a bit better over here. You can see a slight shadow. Another thing that you can give is probably explode. So what explode does is that suppose there is one course that is very important. For example, the next upcoming course is GenAI and I want to make it stand out, right? Suppose the one that is suppose has most students enrolled or the least students enrolled, anything. I want one course to stand out. How can I do that? So either I can give the array over here only or I can have a separate array over here. So I'm going to write a separate array over here. Suppose Gen AI, I want to explode by 0.2%. Now let me actually show it to you. What do I mean by that? How many zeros? 1, 2, 3, 4, 5. And I think that should be okay. And explode. Let's run this. So here you can see that Gen AI exploded out, right? Like it's a bit outside than the rest of the chart. I can make it explode less or make it explode like a lot, right? So 0.2 actually makes sense. So let's let it be 2.2. And instead of putting the separate array, which I actually recommend, you could also do it over here. But okay. And also colors, right? So right now there are by default some colors coming up. Let's copy the same colors and we can also mention the colors that we want. Here I'm going to put it by colors. Again, I can also put colors over here only. I can put the array over here itself or I can just put it like this. So nice. Okay. One very important thing that is actually used over here is auto percentage. So basically I just want to show the percentage for each of the label. So how I can give is percentage, and suppose I want to see till 2 percentages and I'm just going to give like this and let's run it. Oh, sorry about that. And we can see the percentages over here, right, up to 2 decimal places. So if I give 0.1, I will be able to see till 1 decimal place. Let's give till 0.2 for now. Here also we can see the legend. So if you want to see that, we can do that as well. So here you can see, again, I can give the location. Suppose I want to give the location as upper right, I can do that as well, right? But the earlier one looked better, I'm guessing. So sorry. So this is good enough. Let's finally move on to 3D plots and you'll be amazed to see how simple it is, but it is going to look really cool. So give me 1 second. Let's just put the heading 3D scatter plot and let's get started. Here all I need to do is use axis. So what I'm going to do is plot.axis, and when I do that I can actually mention what is my projection. So when I do projection equal to 3D, that means that I am going to be using 3D. And this is all I have to do. Now I can take some x, y, z values and I'm going to just use np.random.rand and I'm going to generate 100 values, and similarly for y and z as well. Let me just copy paste. So this is my y and this is my z, and all I have to do is x.scatter and I can just give x, y, z, and we are ready to see our first 3D plot. Nice, right? And let's just do plot.show and you can see this, right? Nice. Similarly, here also we can do our set x label, y label, right? And I can suppose set it to simple x and y and z. So let's just do this. Also setting the title. And let's run this and you can see this is the X label, this is the Y label, and this is the title. Nice, right? Now that we have made the 3D scattered plot, let's try to do something like this. So here we did scatter XYZ, right? Now we are going to try doing plot XYZ. What they've done is they have done simple linspace and sine and cos combination is giving such a plot. So let's try to do the same thing. So let me just put a quick heading. And let me just copy the projection value line. So X, I can either use np.arrange or I can use np.linspace. It's essentially the same thing. So they are using linspace. Let's do the same thing. So it's from 0 to 1 and they are keeping 100 number of values, right? So in arrange, we give step. Here we give the number of values. Y is going to be the sine function of X and Z is going to be the cos function of X. And let's just do plot. And this is like this. So let's try to change the values. Actually, let's put from 0 to 100 with a step of say 0.1. Okay, the number of values we want is 100. Sorry, linspace. So let me do this. Here you can see something like this. If I do arrange, I think it's going to give me a bit more smoother. Yeah. So you can see something like this, right? If I give 50, I think it will be more spaced out. Yeah, nice, right? Beautiful. Now let's try plotting bar 3D. If we look at the documentation here, so what is given is in bar 3D, they are passing something x, y, z, dx, dy, dz, 6 values. What do these 6 values represent? Let's try to understand. Let me get started with writing the title. Just give me 1 sec. And let me just copy the axis line. And now when I do axis dot bar 3D and I look at the documentation, here again I have to pass xyz, dx, dy, dz. I can pass color and all of this. It says it creates 3D bar plot where the width, depth, height and the color of the bars can all be uniquely set. So if I go down, see x, y, z are the coordinates of the anchor point of the bars. So where the bars are, and width, depth and height of the bars are dx, dy, dz. So let's try to understand this example. See here, if you see just the x, y, z, okay, all these z values are 0. That means the place where the bars are placed. So all of them are placed at the z axis, right? That is why z is 0. And where are they placed? 1, 1, 1, 2, 2, 1, 2, 2. So if the origin is behind somewhere over here, this bar is placed at 1, 1. This bar is placed at 1, 2. This bar is placed at 2, 1. And this bar is placed at 2, 2. Right? So this is how you can understand where they are placed. Right? And dx, dy, dz are the depth, width and the height. So if you see dx and dy are 1 into 0.5. So all of them, all the points of dx, dy are fixed. All of them are same. And that is why if you see the width and the depth of these, so basically not the height, if you see this versus this edge, it's all fixed, right, for all the bars. So that is dx and dy. What is dz? The height of these bars. So 2, 3, 1, 4. This is 2, this is 3, this is 1 and this is 4. So x, y, z is where the bars are placed. Dx, dy, dz is this, like the depth, width and the height. Okay, let's try writing our own code also so it will be clearer. So this will be x, y, z, dx, dy, dz. These are the things that I have to pass and in the end I will just do plot.show. And now let's try writing the x, y, z values. So for x and y, I'm going to just generate some random values. So let's generate some integer values, say between 1 and 10. And I want suppose 5 bars. Okay. And let's generate for y again, same thing, right? So random dot randint, and again I'm going to generate between 1 and 10 and I'm going to generate 5 values. Now for z, I want all the bars to start from the 0 axis, right? The z axis, z equal to 0. So what I'm going to do is just generate an array of zeros And how many zeros? 5 zeros. I could also write like 5 comma 0 comma 0 comma 0 comma 0 like this, but I'm just writing like this one now. Okay, dx is going to be what? It is going to be fixed. So I can just do np dot ones of the size 5. Then again dy is also going to be np dot ones again of size 5, and dz is going to be the heights that I want. So again I can have random heights. So let's do this and let's try running this. Now notice something, every time I run it I'm going to get a different plot, even for scattered, because I was using random, right? So every time I run this I'm going to get a different plot. I hope you are understanding that, because I'm using random numbers. Let me actually print xyz values so that it is clearer. So if I print xyz, dx, dy and dz, and let's check out the values now. Okay, so let's actually run it again. Okay, so let's see. Firstly, there are 5 bars. You can see that, right? And you can see the width and this depth, right? So all of it is fixed. So suppose if I multiply this by 0.5, so this means that dx should be now 0.5 for all the bars and dy should be 1 for all the bars. So you can see that they became thinner, but it's all the same dx dy for all the bars, correct? Now if we see where they are placed, they should be placed at 9, 9, 1, 3, 2, 2, 7, 9 and 1, 6. If you want me to put labels for you to be able to understand better, we can do that as well. Just like we had put labels over here, right? X. So let me actually just copy this. I can also put it over here. So here also you can see x, y, z, and let me put it over here as well. And let me run this, and here also you can see x, y, right? So if you see 4 should be your x, so 4 is my x, and y should be your 7, right? So 4 comma 7. So this is 1 bar, right? Another bar should be at 3 comma 2. So 3 comma 2, here you can see the bar. Another bar should be at 6 comma 9. So 6 comma 9, you can see another bar. Like this you can check it out. And the height of the bars should be 4, 1, 4, 7, 2. So this is 4, this is 1, this is 4, this is 7, and this is 2. Right? Interesting. You can also try it out, play around with it, and this is going to be so much fun. Let's move on to the next 3D plot, which looks very interesting but is actually very, very simple. Plot surface. So I've actually copy pasted this XYZ part, and let me actually paste it over here. It's very simple, okay? So what we are doing over here is XYZ, X and Y are just -5 to 5 with an step, with an increment or with a step of 0.25, 0.25, right? So if I just copy, if I just print these X and Y values, you will be able to see, right? And now if I run this, you will be able to see these are the different x and y values. So now when I do mesh grid, what is happening is I'm converting it into 2D. I'm considering all the possible values of x and y, and I have like a 2D surface. Then I am passing it through a function which is under root of x square plus y square, right? So under root of x square plus y square. And again I am passing that to sine. So this is something like this. Sine of, okay, square root. So just, okay, just think of it this as square root. This is x square plus y square. So you get the point, right? So this is how it is. And first I generated a 2D plane, and now I'm passing it through a function. That is all that we are trying to do. Now let's actually just copy paste this. And now to plot, what I'm going to do is ax dot plot surface. Let me just check over here. Dot plot surface only, right? Yeah. And we have to pass x, y, and z. And let's try running this. So we got a very nice plot. And let me just do dot show. This is nice, right? So by default it comes in blue. You could also give your C map and you could play around with it. Like for example, plasma is one common C map. If I do this, you can see it looks nice, right? Colorful. You could also do inferno. It looks different. And if I do magma, I think that is similar only. Yep. So if I do plasma again, right? Nice, beautiful. So it is very simple, just passing through different functions. All we did was x square plus y square under root, passed it to the sine function. This mesh grid is the important thing. We are just creating the 2D surface by generating all the possible values of xy from this. So we have 1D converting into 2D and then passing it through a function. This brings us to the end of the video. If you have watched till here, I hope you really enjoyed it. I promise you there's so much more quality content coming up, and I promise you you're going to enjoy it a lot. I truly believe that this content deserves to reach more people. I am really working very hard for YouTube. So if you could please hit that subscribe button, you have no idea how much it would mean to me and will really motivate me to create a lot more content. So please do subscribe, share it with your friends, share it on LinkedIn. It would mean the world to me. And see you next time. A lot of content coming up. I promise that to you. See you next time. Bye.